Okay, so I'm gonna talk about the particle nature of light now, and so when we're talking about important aspects of light interactions with matter, we kind of need to go back to a certain scientist who talked about the quantum concept. So let's talk about Max Planck. So, we have a wave model that we talked about, and it doesn't really explain the emission of different wavelengths. Okay. So, when objects are heated, they emit glowing light, and the wave model doesn't really explain it. Max Planck, he began searching for an explanation for this actual phenomenon, and his study actually made him come to the conclusion that matter can gain or lose energy only in small specific amounts called quanta. Okay, so quanta or quantum is the minimum amount of energy that can be gained or lost by an atom. So this is the minimum amount of energy that can be gained or lost. Okay, by an atom. All right. So Planck, Mr. Max Planck, he proposed that the energy emitted by hot objects was quantized. He also showed that there is a direct relationship between the energy of the quantum and the frequency of an emitted radiation. Right? So, when we're talking about this, is basically the energy of a quantum equals E of quantum equals Planck's constant times frequency. Okay, so Planck's constant, H, has a value of 6.626 times 10 to the negative 34th joules times second. Okay, where J is joule, and that is the SI unit of energy, and S is second. Now, this is the formula to find the energy of a quantum. This equation also shows that the energy of a radiation increases as the radiation's frequency increases. Okay? Let's see here. Planck's theory. Planck's theory also states that for a given frequency, matter can emit or absorb energy only in whole number multiples of HV. Okay. Where when we're talking about that, we're talking about you can only absorb energy in one H nu, and I'm going to call it HV to make it easier. Okay. One, or I'll just stay with it. H nu. It can be 2H nu, 3H nu. So whole number multiples, that's what we're talking about. And so on. Okay. Etc. Now, when we're talking about this, we can actually kind of do an analogy with a child building a wall with wooden blocks. So a child can only add to or take away from this wall only in increments of whole numbers of blocks. So you can only add one block at a time. It's not half a block, a quarter block. It's one block at a time, right? So you need to use basically one block at a time. I'm using Legos here.